going to go over the answers and how to work out some of these problems that we did in class. So this is kind of an AP style. We have an area, and then we progress to volume, kind of using the same functions. And you notice this is no calculator, so all these integrals should be without your calculator. So just to save a little time on here, I sketched a graph. This is a parabola shifted up 1 and a line starting at 0. You go up 2 to the right 1. So you can kind of tell that point of intersection. If you want, you can solve to find the point of intersection. And you realize there's only one place, and you can see it on your graph where they intersect, and that's at x equals 1. Okay, so if it says find the area enclosed by these two functions, it's usually meaning that and the y-axis. So we're talking about this little section right here. So my integral will be the top function minus the bottom function. So it'll be the integral from 0 to 1, that's our intersection points, of the x squared plus 1 minus 2x dx. And you need to integrate this. You need to practice integrating easy ones like this. So we have x cubed over 3 plus x minus x squared. Pretty easy integral. Raise it by 1, divide by the power. And that's from 1 to 0. So we plug in 1 and get 1/3 plus 1 minus 1. And when you plug in 0, you're going to get 0, 0, 0, 0. So 1 minus 1 is 0. The area is 1/3. And you can check it on your calculator, but you would not have it at this point. Okay? Second question. Find the volume when the area enclosed is rotated around the line y equals 4. So if you go up, this is 1, 2, 3, somewhere up in here. Okay, we're rotating around that line y equals 4. So you have to ask yourself, horizontal axis of rotation. Bounds are on the x-axis, and it has to be in terms of x. So we're good there. It's anything that is parallel to the x-axis, we can keep it in terms of x. So I have to look and say, okay, I'm rotating up away from the axis, so I'm gonna have to use some things that I know from my picture. I know that I'm gonna have a hole because we're gonna have a big radius minus a little radius. So I know I'm gonna still use the same bounds, 0 to 1. And the big radius this time is the line, and the little radius is the parabola. So the trick is that it's not just the line by itself. Okay, so 2x is the distance from the line to the x-axis, but we're going the other way. And the other way is 4 away from the x-axis. So it's going to be 4 minus 2x. That's the big radius. Minus 4 minus x squared plus 1. Worth double checking. Parallel to the x-axis, bounds on the x-axis. Make sure you remember that your function tells you the distance to the parallel axis there. So if you are going to find the volume here, you need to expand this polynomial. It'll be easy once you expand it, but be careful, use your algebra. So 16 minus 8x is minus 16x plus 4x squared. And then I'm going to combine this into 3 minus x squared before we square it. Minus the quantity. 3 minus x squared, that's going to be 9 minus 6x squared plus x to the 4th. And you know we're subtracting the whole quantity, so just be careful there. Combine like terms. I have a 6x squared and a 4x squared, so that is 10x squared. It doesn't really matter what order you put them in, just make sure you get them knocked out of there right. And we have a 16 minus 9, so that's 7. And a negative 16x and a negative x to the fourth. And so that is what we actually integrate. And I'm going to let you integrate that to save time on here. Just all power rule. You're only going to plug in the 1. You're not going to have to plug in the 0. The last one, again, progressing with our same thing, the base of rectangular cross sections perpendicular to x-axis. So as long as it's perpendicular to x-axis, everything stays the same. 0 to 1. Only on our little enclosure there, this is kind of what the enclosure looks like. We have rectangles coming off of this page where the base of the rectangle is our distance across, which we already found. It's the parabola minus the line times the height, which in this problem says the height is 2. So you have a rectangle. The height is 2. The base is x squared minus 2x plus 1. And there's a whole bunch of them we're adding up all the way across from 0 to 1. And so to integrate, x squared minus 2x plus 1 dx, 0 to 1, x cubed over 3 minus x squared over 2 plus x. And so we already actually integrated this up here, and we got 1/3, so that the volume is 2/3. And think about what volume is. The area of the base times the height is the volume. The area of the base was 1/3. We did that up here, and the height was 2. 1/3 times 2. This goes back to geometry. Area of base times height is volume.